What if the universe wasn't meant to exist? This profound question arises when we consider the delicate balance of fundamental physical constants that govern our cosmos. If gravity, electromagnetism, or even the mass of the proton were slightly different from their observed values, life as we know it would never appear. The very fabric of reality seems to hang by a thread, poised on the edge of existence. Yet, despite these incredibly precise requirements, everything in our universe seems perfectly balanced. It's as if the cosmos itself is tuned with an extraordinary purpose, allowing for the formation of stars, galaxies, and ultimately, the complex life forms capable of contemplating its origins. This remarkable precision is not merely a coincidence, but a profound mystery that has puzzled scientists and philosophers for decades. Scientists refer to this astonishing phenomenon as fine-tuning. It describes how the fundamental constants of nature, from the strength of nuclear forces that bind atomic nuclei to the expansion rate of space itself, all fall into an unbelievably narrow range of values. These constants are not arbitrary. Their specific magnitudes are crucial for the universe to be life-permitting. Any significant deviation would lead to a radically different and likely barren cosmos. Consider the implications. Even a minuscule 0.000001% change in certain constants would have catastrophic consequences. For instance, such a tiny alteration could cause stars to collapse prematurely, preventing them from ever forming in the first place, or disrupt the delicate processes that allow them to shine for billions of years. This highlights the extreme sensitivity of the universe to its foundational parameters, underscoring the idea that our existence is contingent upon an almost impossibly precise set of conditions. Let's delve deeper into specific examples. If gravity, the force that pulls matter together, were much stronger than it is, stars would burn through their fuel at an accelerated rate, collapsing into black holes or neutron stars far too quickly for life to evolve on orbiting planets. Conversely, if gravity were much weaker, it would be insufficient to draw together the vast clouds of gas and dust needed to form stars and galaxies, leaving the universe a diffuse, featureless void. The precise strength of gravity is therefore essential for the cosmic structures we observe. Similarly, a slight change in the electromagnetic force, which governs interactions between charged particles, would have profound effects on chemistry. This force dictates how atoms bond together to form molecules. If it were even slightly different, the stable chemical bonds necessary for complex molecules like DNA, proteins, and water would be impossible to form. Without these fundamental building blocks, life as we know it, based on carbon chemistry, could not exist anywhere in the universe. The cosmological constant, a term in Einstein's equations of general relativity, governs the expansion rate of the universe. Its value is incredibly small but positive, causing the universe to expand at an accelerating rate. If this constant were too large, the universe would have expanded so rapidly and violently in its early moments that matter would have dispersed too quickly, preventing the gravitational clumping necessary for galaxies, stars, and planets to form. The universe would be a vast, empty expanse. Conversely, if the cosmological constant were negative, it would imply an attractive force, causing the universe's expansion to slow down and eventually reverse. In such a scenario, the universe would have collapsed back in on itself shortly after the Big Bang, long before any complex structures or life could ever emerge. The precise, near-zero value of the cosmological constant is therefore critical for a universe that endures long enough for life to develop. The masses of elementary particles, such as protons and electrons, are also incredibly crucial. The precise ratio of their masses affects the stability of atoms and dictates the types of chemical reactions that can occur. For instance, if the electron were significantly heavier, atoms would be unstable, and if the proton were much lighter, nuclear fusion in stars might not proceed as it does, altering the production of elements essential for life. This delicate balance ensures the existence of stable atoms and the rich chemistry that underpins biological processes. Faced with this extraordinary fine-tuning, various explanations have been proposed. Some scientists and philosophers argue that it is simply a result of pure chance, a cosmic lottery where we happened to win the jackpot. Others posit the existence of infinite universes, a multiverse, where every possible combination of physical constants exists, and we simply find ourselves in one of the rare universes capable of supporting life. These perspectives offer different ways to grapple with the apparent improbability of our existence. But what if this astonishing precision points to something more profound than mere chance or statistical probability? What if it suggests an underlying intention, a signature of order meticulously written into the very fabric of reality? This perspective invites us to consider whether the universe's fine-tuning is not just a random outcome, but a deliberate arrangement, hinting at a deeper meaning behind our existence and the laws that govern the cosmos. Perhaps, then, fine-tuning isn't merely proof of randomness or the vastness of a multiverse, but rather an indication of profound meaning. It challenges us to look beyond the purely mechanistic explanations and consider the possibility that the universe is not just a collection of particles and forces, but a system imbued with purpose, where every constant and every law contributes to a grander design. This perspective transforms the scientific observation into a philosophical inquiry about the nature of existence itself. AYATIUM explores these profound questions, venturing into the fascinating intersection where cutting-edge science meets timeless faith. We delve into the mysteries of the cosmos, seeking to understand how every equation, every physical law, and every fundamental constant might hide a deeper sign, a clue to the universe's ultimate nature and our place within it. Join us as we journey through the wonders of creation, from the smallest particles to the grandest galaxies. Subscribe to AYATIUM and embark on a journey of discovery, exploring how the intricate design of the universe suggests that every atom whispers purpose. Uncover the scientific and philosophical insights that reveal the profound meaning embedded within the cosmos, and see how the delicate balance of existence points to a universe that is not only finely tuned, but also deeply significant. Join our community and explore the wonders of science and faith.